Okay, let's look at this OCW. We have a bar AB, from here to here, that's a bar. And there's a load which is 120 Newton. It's acting at the midpoint of the bar. So acting at the midpoint here. Of course, the load is always following gravity. 120 Newton. Okay, the length of the bar is 3 meters. So this is the length of the bar, 3 meters. Determine the tension of the string BC. So he wants to know the string here, BC, and the reaction at the support here AY, and here AX. This is a hinge, so AY AX. D1 is 3.8 meter, and the angle is 20 degrees. Okay, so now we'll do the we'll open up my calculator. Okay. Now we need to find out the slope of the bar AB. So let's look at the slope. If you go from here, and you could create a triangle, and if the whole thing is 3 meters, so if you draw a triangle like this, if the whole thing is 3 meters and this angle is 20 degrees, so what is this? This is sine. This is sine 20. Let's just call this y. Is equal y over 3. So this is equal 3 sine 20. Okay. How about if you want to call this one x, and for the x is cosine 20, and that is x over 3. So this is 3 cosine 20. Okay, so let's find out cosine 20 and sine 20 and put the numbers. 20, let's say the sine first, times 3. This is here 1.0261 meters. And let's look at the cosine 20 times 3, and that is 2.82 meters. So now we have the slopes of AB. Let's find the slope BC. For BC, we have to look at the following distances. Distance from here to here. If this is 2.82 from here to here, plus 1, that's going to be 3.82. Remember, 1 meter all the way down to the wall. 3.82 meters. And if the whole thing is 3.8 meter, what is this? This is 1.026. So 3.8 minus 1.026. Okay. 3.8 minus 1.0261. 1.0261, and that is this one from here to here. It is 2.774. Now, if you want to find out the diagonal, so this is the slope, 2.82, 2.774. So this is square plus 2.82 square. Okay, under square root, and this is, so this is 2.822. Let's do it again. Okay, this is going to be 4.721. Okay, that's the slope. Let's draw the free body diagram with all this angles and distances. Okay, so this is the bar. This is A, B. And this is the reaction. AY, AX. Okay. This is AY, this is AX. And that is, let's see, the slope here. This is the tension BC, and you have the slope. The slope gonna make 1 in the X, tension BC in the X, 2.82 over 4.721. That's gonna do 1 in the Y, tension BC, 2.774 over 4.721. Okay, 2.82 over 4.721 and 2.774 over 4.721, and that is 1 in the X, 1 in the Y. So let's ignore this since we make it 1 in the X, 1 in the Y. And now, the best, as we mentioned in class, the best things to find the tension is to do summation of moment at a point where there's too many unknowns. But before we do that, let's find out the weight first. There's a weight here in the center, and that weight is 120 Newton. Let's complete the triangle here. And this is 20 degrees. And he said that it is at the center, so this is going to be 1.5 meter. So since we have an angle, 1.5, this is 1.5 cosine 20. And this one, 1.5 cosine 20. Let's do moment at A. Summation of moment at A equal to 0. And I'm assuming this is negative clockwise. So this will make, this force will create a negative moment, 120. Of course, distance that is perpendicular, it's this one, 1.5 cosine 20. This force will produce a positive moment plus TBC 2.82 over 4.721 times distance, which is perpendicular if you just extend it like this. So this is the distance that is perpendicular, and that's going to be this one, 1.0261. 1.0261. This force will also produce a positive moment, TBC, which is 2.774 over 4.721, 2.774, 4.721 times the distance now, this distance, which is perpendicular to it, and that is 3 cosine 20, which is 2.82. 2.82, and that is equal to 0. So let's look at the answer here. Okay, so we're gonna do it like this. Let me just check it. 1.5, 1.5, 120, 1.5 cosine 20, TBC 2.82. Is it 2.82 or 3.82? 1.0261. 2.82, okay. 4.721, okay, times 1.026, and the last one, 2.774, 4.72, TBC, 3.82. Okay, so let's look at this. First of all, 2.82 times 1.02, 1.0261 times 2.82 over 4.71. TBC would be equal to So TBC will come to equal to 68. 68. Now let's do summation of forces at X. Equal to 0. AX. And now this is not in the X, this is in the X. Minus TBC 2.02 over 4.721. Well, we have TBC 68. We put TBC here 6.68, and this is equal to 0. You could find out AX. And that's going to be, let's look at this. Okay. AX is equal to 55. This is going to be AX 55. And if you want to find Fy, summation of forces of y equal to 0. And this is equal to AY minus 120 plus TBC 2.741 over 4.721 equal to 0. And then you're going to find AY. AY is equal to 80. 80 Newton, and distance is up. Thank you.